So, when it comes to the proofs, I'm sorry, I should be looking at maths. Physics. What am I doing? No, it's not physics, it's maths. Goodness sake. Maths part 2. The book. With proofs, there's no one way to do a proof. You know, it's not like, here's a quadratic, here's how you solve it. With the proofs, you need to think for yourself, which I know is difficult sometimes. Nobody likes to think. All I can say with the proof is that in the exam, there's two main types of proofs when it comes to vectors. The first type of proof is what I would call like an algebra proof. And the second type of proof is like a diagram proof. So you can prove it by using algebra, or you can prove it by using a diagram. Okay? I will do one example of each, and then what I think might be good is if we take some turns doing some proofs today. Yeah? Good, Mr. Sharif? Yeah. So, first one we'll prove. Number 1. X is a vector in 3 dimensions. Does anyone know what RPT stands for? Probably not. It means required to prove. So what I required to prove here is that x dot x is equal to the magnitude of x squared. Oh, good coffee. I need it. Okay, so the proof, this is an algebra style proof. To start a proof, you draw a little triangle. This means the beginning of your proof. So what you do is, for this one, I would say something like, let x equal, vector x equal xyz. Something like this. Just so I can have, or if you don't like that, you could use x1, x2, x3. Which do you prefer, xyz or x1, 2, 3? XYZ? Yeah, okay, so we'll go with XYZ. So, if I start with x dot x, that would equal XYZ dot XYZ, which would equal squared, yeah, x multiply x squared plus y, yeah, plus z squared. Now, if I look at the magnitude of x squared, that's equal to square, and then what's the magnitude of x, if this is x? Square root x squared plus y squared plus z squared, which equals x squared plus y squared plus z squared. So therefore, left hand side equals right hand side, x dot x, which is this, is equal to, it's the same thing. These two have to be the same because they're both equal to x squared plus y squared plus z squared. So that's equal to magnitude of x squared. And then to show that your proof is finished, you can either write a square at the end, which means end of proof, or what I prefer is QED, which also means end of proof.
Where you know the
star? Outrageous, unacceptable. I want a square or QED. Yeah. I'll go with QED. So this is, do you understand why I call this like an algebra proof? Why do you think I call it an algebra style?
No, it's not that style. It's hash.
Hash, yeah. That's what the Chinese students use as well. I don't know, maybe in Europe we use a square for QED. Wait, before you write this down, why am I calling this an algebra
Because
proof?
we are doing algebra, like all the stuff.
Yeah, because you're doing like x squared, y squared, z squared. It's algebra approach. Okay, now you can write it down. Yeah. Yeah? Continue? Okay. So now let me do one that is a diagram type of proof. I'm going to do... No, I want to do the one with the circle. Yeah, which is... Oh, it's funny enough, it's the last one. So I'm doing the first one and the last one. So the last one here, you might remember this from middle school. If you have a circle and you draw if you have a semicircle and you draw a triangle from one end to any point on the arc to the other end, this is always a right angle. It doesn't matter where you draw it on the circle. You always get right angles on the top. Have you seen this in middle school or not? No, you haven't?
Nothing.
Maybe. Okay, well, do you understand it?
Yeah.
So we want to prove this using vectors. So with the diagram proof, what you do is you give each point on the diagram a letter. So to me, because this is the center of the circle, I should call that O. It just makes most sense.
What do you want to prove?
That this is always a right angle. We need to prove this triangle is always a right angle where the hypotenuse is equal to the diameter. So if the hypotenuse is equal to the diameter, then you're guaranteed this other point on the circle will form a right angle triangle. That's what we're trying to prove. Is that okay? Yeah? Okay. So what we do is we like to give the point a name. I'll call that point OR. I'll call that point A. I'll call that point B. And I'll call this point C. Why not? C. So what are we required to prove if I want to prove that this is a right angle? As a vector, what am I trying to prove? If you can think. Not that it's a unit vector, but you're thinking maybe something else. How can I write this as a fact about vectors? What am I looking for here? What do I need to try and prove?
That is right angle 90 degrees.
What's a right angle exactly? No? No, no, yes, yes, no, yes. Give me something. If you don't know, that's fine, but I need to know if you don't know. You don't know? Okay. So, we're trying to prove that the vector CA is perpendicular to CB. Make sense now?
Yeah.
Which means that's the same as proving that, no, over that, proving that CA dot CB is equal to 0 if they're perpendicular. You're thinking of semester 1 with the -1. Yeah. So far okay? Now what is the formula for CA? A minus C dot B minus C equals 0. So if you expand this, you get A dot B minus A dot C minus C dot B plus C dot C equals 0. What is C dot C?
C squared.
Magnitude of C squared. Yeah. Is A dot B anything? A dot C?
AC plus CB.
AC. Oh, you mean put these together?
AB equals AC plus CB.
Oh, very good. Like change them. Yeah. I was thinking though, if you look at this picture, you know, it's good to be thinking, but I was thinking, and you can give me your opinion, you can say B equals minus A. Because vector B is the same as just minus A. Yeah? I'm going to change these B's to minus A's. So this would be minus A dot A minus A dot C plus C dot A. Now something cancels here. These cancel because A dot C and C dot A are the same with the minus, and this one becomes minus magnitude of A squared plus magnitude of C squared equals 0. But A squared, its magnitude, that's the distance from here to here, which is the radius of the circle, isn't it?
Yes.
And what about C squared? What's the magnitude of this? It's the same, isn't it? Does this equal 0? So,
Is this using the diagram?
well, it's actually kind of using both. It's using the diagram to make, wait, I won't go ahead, don't worry, we have plenty of time. We're using the diagram to make this statement, which we make into this. So this one is using the diagram, but then for the rest of the problem, we're using algebra. But the key, in my opinion, the key was this diagram. And also, I needed to use the diagram for this part. And where else? Oh yeah, and for this part. You know, so I needed the diagram to be able to see this and to be able to see this. It's kind of a mix of the two. Okay, write this down carefully, please.
When it's perpendicular, why did we write CA dot CD is equals to 0?
Say again?
Why it's not the way we do it in slope and all the stuff?
Did you miss that lesson?
Last lesson?
You must have missed that lesson. We did a lesson on perpendicular. It was a lesson called dot product.
I haven't done that.
No, sorry. A lesson called angles.
Oh.
Do you have a lesson called angles?
No, I don't know.
It was explained in this lesson.
This is the last lesson.
Is it the last lesson, angles? Yesterday?
The angle between two vectors.
Yeah.
Last lesson.
Were you here yesterday? Ah. That explains
No,
it. Yes. Yes. See what happens? So you'll need to watch the video. Did you watch the video?
I'm watching the video.
The answer is you did not watch it then, because you said you will watch the video.
I'm watching the video.
No. Yeah, but have you watched this video? Okay, so you'll need to do that then sometime soon. Our next maths class isn't until next week, so you would want to do it before next week. You probably want to finish the coursework first though as a priority.
Today.
Today? It's not due till Monday. But if you want to send me a draft, I'd be happy to take a draft and I can give you feedback on it, no problem. I always give you feedback on drafts, don't I? It might take a few days, but I always give you feedback. Okay, did you write this? You're writing this down. One moment. You have to wait for someone. This is different.
For the first time.
For the first time. Now, the good news is, proofs are not common on the exam, which is, I know, good for you, because proofs can be a pain, and sometimes proofs are hard. And there's only one other lesson left, and then the vectors is finished, and we'll go back to trigonometry. So we'll get vectors finished today. I would like you now to prove 2 for me. So let me pick out 2 for you to prove. That would be good, and you can write them down. Yes, actually, I think this would be a good one to prove. Number 3. If you can write this down, you want to try and prove this.
Why did you change your mind?
About what?
You said 2.
No, 2 questions.
Let me start with 2.
So number 3, I want you to prove 2 questions. I'm giving you the 2. The first one is number 3, and then the second one, well, can you just write this equation down? I want you to prove this. Okay, and let me just zoom out a little. Okay, number 3. Have you got that? Right, and let me think of... Some of these are hard. Try number 10. Now, wait, I think it'd be easier if I draw what I mean in number 10. I'll read it and then I'll draw what I want. Prove that if the diagonals of a rectangle are perpendicular, then the rectangle must be a square. So what I want you to prove is, if you have something that you think is a rectangle, but if the diagonals are perpendicular, so, okay, here, if I draw this, these are definitely not 90 degrees. What I want you to prove is that if they are 90 degrees, then what you actually have is a square. So, prove it is a square if the diagonals are perpendicular. Do you understand what I need you to prove? I know you might not understand how to prove it, but it's like the example I gave. So what do you think you mark as O? Where would you put O? Where? In the middle. And we'll call this like A, B, C, D. And what are you trying to prove here?
The diagonals are perpendicular.
Yeah, so what's that as a vector?
DB and AC.
Yeah, if you want to prove that DB, for example, is perpendicular to AC, then, I mean, you start here, you know that DB is perpendicular to AC.
Yeah.
From starting there, you need to end up with something that proves you have a square. So you're trying to end up with something like DA magnitude equals AB magnitude. So if you can start here, knowing that these are perpendicular, and end up with this result at the end, then you proved that it's a square. Now, I wonder if I give you a hint. Hint. Look at the diagonals which are perpendicular. Yeah. Nearly the same, not much different, yeah. Okay, let me close this, and then when you're ready, we'll have a look at the answers. Okay, so those two now.